Hello and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of rate of change. This is standard A.3B in the great state of Texas, and we are using item number 38 off the 2016 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we have got a graph showing the volume of gas, how it changes as the temperature changes and the pressure remains constant. So we're simply looking for the rate of change, and the two things we're looking for is the volume of the gas sample with respect to the temperature. So this with respect to lets us know that we're going to be making a ratio here. And so volume of gas, that's going to be our numerator. We're going to make a ratio, and then we've got the temperature. That's your denominator. And so when we're looking at the volume of gas, right, that's your y-axis right there. And then my temperature, that's my x-axis. And we're looking for the rate of change. So we're looking for the change in y. That triangle is actually a Greek letter delta, which means change. So the change in y over the change in x. Hopefully that sounds familiar. Sometimes we'll call it rise over run, which means, yeah, we're looking for slope. We're looking for the slope of this particular line. So that's what represents the rate of change, is that slope. All right, so how do we do that? Well, we know the equation for slope, right, is going to be y sub 2 minus y sub 1, that's my numerator, x sub 2 minus x sub 1 as my denominator. What do we know about the slope just by looking at it? Well, it is going to be positive because it is moving up when it goes from left to right. I don't see any negative here, so we can't eliminate any of those. I do know from experience that the greater the whole number, the steeper the slope. And I've got questions about these two. This looks like kind of a gradual slope. It's not very steep, because look at just how it's counting by ones. It's counting by ones over on the y-axis, but it's counting by, looks like by fives over here on the x-axis. So I'm thinking it's gonna be a fraction. I'm thinking f or g look a little bit better, but we'll do the work to figure it out. So they don't give us any points here, right? And we've got a lot of near misses like that right there. That looks like it might be 522, but that looks like it might be a little bit below. So that's the difficult part. You need to find points in which it looks like it's exactly crossing, right? So that's going to be an x of 30. I've got one right there. And then a y of, that's 24. All right, so I'm just going to go up the line. All I need is one more. Maybe that right there. Looks like it crosses a little bit above. This one right here looks like it crosses a little bit below. I'll use those if I need to. Oh, there we go. All right, so that looks like a pretty good spot right there. 90, and that's going to be 29. So this spot right here is close. This spot right here is close. This spot right here is close. But if they don't give you any points, don't pick the close ones. Find ones that are exact. So let's make this my x1 and my y1. Let's make this my x2 and my y2. So that's going to be 24 minus 29 over 30 minus 90. All right, so that's negative 5 over negative 60. That's fine. They'll both end up being positive since they cancel each other out. Divide both by 5s. And 5 goes into 5 once. 5 goes into 60 12 times. And there we go. We did see that it was a very small gradual slope. And I have 1/12 right there as G.